Alright, problem number 4. Circle A has a radius of 100 and circle B has an integer radius of r that's less than 100. Okay? And it remains internally tangent to circle A as it rolls around the circumference of A. Okay, so you could imagine this smaller circle sort of rolling around on the inside of A until it ends up back where it started. Okay, sort of like a spirograph. I don't know if you guys have ever played with the toy called spirograph, where you put your pen in. You have two circular discs with kind of these teeth on them, and they the mesh up and like gears kind of, and they're you put your pen in the smaller circle, and it draws a cool shape as you as you roll it around the inside of the larger circle. So anyway, we have it says they remain internally tangent, which just means that this as this rolls around inside of the bigger circle, that that circle B is internal to circle A, and that they always are touching at one point as it rolls around. Okay, and it says that the two circles have the same point of tangency at the beginning and end of B's trip. Okay, so the point of tangency in this snapshot here is right here. It's the point where the two circles are touching. All right, and if they have the same point of tangency at the beginning and the end, then the point on B, right on B, if we were to keep track of where that point is as it rolls around, that same point ends up at the back at the same point on A. Okay, so they're touching at the same point again. So, and the question asks, how many possible values can R have? All right, so R is an integer. It says it's an integer. And let's take a look at the two circumferences. Okay, so the circumference of, so let me write that out, circumference of A, we can calculate that because we have all the numbers, is 2 pi times the radius, right? Or pi times the diameter. So that would be 200 pi, all right? And the circumference of B is what? It's 2 pi r, right? 2 pi r. We don't know what r is. But in order for these two circles to have the same point of tangency at the beginning and the end of B's trip as it rolls around the inside of A, the circumference of B has to be an integer multiple of the circumference of A. Okay? Because you can imagine that you essentially, as you roll B around, it when it goes one time around, then the portion of, let's say it ends up here, and there's another point of tangency here where they match up. Once B goes a full goes around once, the portion of the circumference of A that's traced out is just 1 times the circumference of B. Okay, so in order for it to end up where it started, it's got the circumference of A has to be an integer multiple of the circumference of B. Okay, so let's take a look at the ratio of these two circumferences. Okay, so because we know that the ratio of these two circumferences has to be an integer. Okay, so if we take 200 pi and divide it by 2 pi r, the pi's cancel out. Pi over pi is just 1, and 200 over 2 is just 100, so I can make this 100. So we know that 100 over r has to be an integer, okay, in order for the circumference of B to be an integer multiple. Wait a minute. Circumference of A needs to be an integer multiple of the circumference of B. Alright, so in order for that to happen, the ratio of their circumferences has to be an integer. So we know this has to be an integer. So that means R has to be a factor of 100. So let's take a look at the factors of 100, right? I'm going to write them out like this. So we have 1 and we have 100. And we have 2 and we have 50, right? We have 4 and we have 25. And let's see, we have 5 and we have 20. I better put commas in here so they look separate. And what else we got? We got 10 and 10, right? 10 and 10. I don't need to list them twice. So essentially these are all the factors of 100. And to make we can make sure that we have all the factors by looking at the prime factorization of 100. So 100 is just 10 times 10, which is 5 times 2 times 5 times 2. So it ends up being 2 squared times 5 squared, right? That's the prime factorization of 100. So, if we wanted to know how many factors there are of these, we can actually look at, if we know how many factors that there are of 100, we have essentially 3 choices for the power of 2. We can have a factor, power of 1, 2, or 0, 1, or 2. All right, and we have 3 choices for the power on 5. We can have 0, 1, or 2, and all of the different combinations of those powers will give us the number of factors. So it's just 3 times 3, right? So 3 choices for the power on 2, 3 choices for the power on 5, and so we have 9 factors. Now do we have 9? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 factors. So we've got them all. All right. So we have to be careful because it says that the radius of R has to be less than 100. Okay, so let's cross that one out. It can't be 100 because then the 2 circles would be just, they'd have all of their points as points of tangency, and you wouldn't have room for B to roll around inside of A, right? So that leaves us, we had 9 factors, and so now we have 8 factors. Okay, 8 factors. And so, what does that mean? That means that we have 8 possible values for R, so that the radius of A is an integer multiple of the radius of B. Okay, so we have a total of 8 possible radii. Okay, and here they are. The radius could be 1. Okay, and then how many times would that go around the inside? It would end up going 100 times around, and end up with the same point of tangency. If we had a radius of 2, then it's going to go 50 times around the inside of the bigger circle. Okay, and so on. You can think through all of those, but all of these radii will end up with the same point of tangency at the end. Okay, so we have 8 possible radii.